So now we're going to continue on to isosceles and equilateral triangles. So tonight's homework will be a worksheet. Your homework for over the weekend will be out of the book, and it will be on this material. Okay? All right, so just a reminder, if you have forgotten this, the parts of an isosceles triangle, or it may be that you never learned these. The two congruent sides of an isosceles triangle are called the legs. And at this point, you can insert a bad joke that if one of the legs was shorter than the other, it would walk in circles all the time. The other side is called the base. Let me just say that we used to call it big G geometry, which is what this class is. Base doesn't always mean on bottom, right? Because if I turn this a different way, have I changed its properties? No. Now, when you first learn about this, the base of the isosceles triangle is always what's on bottom. That will not be true in this class, okay? The base will be the side that's not congruent to the other two. The angle that's opposite the base is called the vertex angle. And students in the past have said, well, that's the direction. If you think of the isosceles triangle as being an arrow pointing somewhere, that's sort of where the arrow is pointing. Whether it's, whether it's something like this, or you have a really narrow one, or even if you have an obtuse isosceles triangle, the direction that it's pointing is the vertex angle. Okay? The other two angles, which are at the ends of the base, are called the base angles. So partly why you need to know that is to understand this next theorem, which says in an isosceles triangle, the base angles are congruent. And at this point, we don't have enough to prove this theorem. You're actually going to have to wait until after we learn the unit after this one before we can prove it. But I think you can demonstrate it pretty well. Don't worry about drawing this in, but everybody think about this. If I took this triangle and I folded it along this dotted line, would this base angle fit exactly over that base angle? Yeah, it's because these two triangles, if I drop it in like this, so that that's at a right angle to the base, these two triangles are going to be congruent to one another. So all their matching pieces are congruent. We'll get more into that later. So that'll allow us to do things like this problem. Find the measure of the other angles in each triangle. All right, so here we have an isosceles triangle. These are the two legs, so that means that this side is the base. So the two base angles are going to be the same size. So which two angles in this picture are going to be the same size? S and T. So T will be 78. And then we can find angle R by adding 78 and 78, which is 156. Yeah, subtracting it from 180, exactly right. So that's going to leave me 24 degrees for this. Sometimes instead of giving you a base angle, they'll instead give you the other angle, which is called the vertex angle. So which two angles will be the same measure in this one? J and K are going to be the two that are going to be congruent. So I'll subtract 86 from 180, which leaves me with 94. And I'll split that because J and K add up to 94 and they're equal to one another. So I'll split that in half and each of these will be 47. All right. Let's go on to the back. It turns out that the converse of the isosceles triangle theorem is also true. If you start off knowing that two angles of a triangle are congruent, then you know that they're base angles of an isosceles triangle. So let's take a look at this problem. Find the length of each side of triangle JTD. I'm given the three sides in terms of x, but the sides of a triangle don't add up to anything in particular. But what do we know about the angles? What do we know about these three angles in this triangle? They've got to add up to 180. So let's see what the other angle is. 58 and 64 is 122 from 180 is 58. Oh, hey, look at that. So which two angles are the base angles? J and T. Which means that the side that runs between them is the base. And what do we know then about the other two sides? They're the legs, which are congruent to each other. Exactly right. So that means that 3x plus 7 is equal to 5x minus 11. So 2x is 18, so x is 9. So now I can find the length of each side. The length of segment JT is going to be 2 times 9 plus 15 is 33. And the length of JD should be the same as the length of TD. So that's 3 times 9 plus 7. It's 27 plus 7 is 34. If we had substituted into the 5x minus 11, we would also find that those two are 34. And again, the sides of the triangle don't add up to anything in particular. Their sum is called the perimeter, but we don't know what the perimeter is automatically. Now, a couple of corollaries that come from this. What if instead of knowing that just two of the sides were equal, what if all three of the sides were equal? Well, then you could call any two sides the legs and any side the base. And so they're all bases, and so all the base angles are going to be congruent to each other. So that's why if a triangle is equilateral, it is also equiangular. And vice versa. If a triangle is equiangular, it must then also be equilateral. Typically with triangles, people call them equilateral triangles. I think maybe because it's slightly easier to say, but if you say equiangular triangle, it's the same thing. An equilateral triangle is equiangular, and an equiangular triangle is equilateral. By the way, is that true for other polygons? If you have a polygon that is equilateral, does it have to be equiangular? Can you give me an example? I agree with you, by the way. A rectangle is the other way around from the way I said it, but yeah, a rectangle is equiangular, but does it have to be equilateral? No. What's the name of an equilateral quadrilateral that is not equiangular? Yes. Melody, was that you? Yeah. It's a rhombus. A rhombus is like a square that got pushed part way over. Only in triangles do we know that if the triangle's equilateral, it's equiangular and vice versa. It doesn't work for any other polygon. All right, let's do this example. So here, we've got that these two sides are congruent. So what are those sides called? The legs. So what's the other side called? The base. So we know that the base angles are the ones that are congruent. Which two are the base angles? L and T. So the measure of angle L is also 3x plus 5. Then, unlike the sides, what do we know about the angles in any triangle? Yeah, their sum is 180. So 3x plus 5 plus another 3x plus 5 plus 4x is equal to 180.
10x plus 10 equals 180. So x equals 17.
Yeah. So x is 17. So the measure of angle M is going to be 4 times 17, which is 68 degrees. The measure of angle T and the measure of angle L,
56.
let's see, 3 times 17 plus 5, that's 30, 51, 56. You're exactly right. And the crowd goes wild. Hey, any questions about that? Okay, and then again, as I said, this material will be on tomorrow night's homework. And tomorrow in class, what you're going to do is you're going to go over the answers to tonight's homework. Then I want you to, after we've gone over the answers, I say we, after you all have gone over the answers, to, if anyone has any questions, I want you to help one another, okay? Since I can't be here to answer any questions, if you have questions, talk to some people. There's bound to be somebody in the class who knows how to do it if you had problems with anything. And then you'll spend a few minutes doing that, and then you will have lots of time to work on tomorrow night's assignment out of the book. I would imagine you can finish it before class is over. Okay. Last thing is that tomorrow and Monday, you will be turning in homework, but you'll be turning it in Google Classroom. Okay. You gave me an odd look.
I just remember once it would work, because you can't take pictures on the computer with it to turn it in.
You can.
You can?
I don't see why not.
There's a front camera.
Oh.
You can also take pictures with your phone if you've got Google Classroom on there. Okay? And if somebody needs help getting, their stuff turned in, I've also told the sub to give y'all a few minutes at the beginning of class to get the homework turned in on Google Classroom. So if anybody needs help, again, please help each other out. I would appreciate it very much.